Hello and welcome. Thank you so much for joining us. This is the Learn How to Teach Climate Science with NSTA's Sense-Making Approach, and this is presented by the National Science Teaching Association. I'm Cody Coltharp. I'm from the Smithsonian Office of the Undersecretary for Education, and I am sincerely delighted to have all of our colleagues from the NSTA with us today. So in the workshop, in the session today, you'll see how their lessons are presenting climate change as this problem-solving opportunity, and how they give the students all the tools that they need to carry out investigations and design solutions to address these challenges. You're going to learn how to use these materials to drive student learning and also inspire them to examine critical climate issues in their own communities. So joining us today are two workshop facilitators, are Holly Hero and Patrice Sinta. For Holly, she strives to ensure that all students have access to high-quality science learning experiences. Previously, she worked at the BSCS, Northwestern University, and University of Colorado Boulder, in both developing high-quality NGSS-aligned high school and middle school storyline units. She also taught high school science in Michigan for 15 years. In her role at NSTA, Patrice strives to develop high-quality instructional materials that engage all students and enhance science teachers' content and research-based pedagogical knowledge. Previously, she was a general science teacher and instructional coach in the New York City Department of Education and the San Francisco Unified School District. Please hit those emoji applauses and hearts for both Holly and Patrice. I'm going to shift it over to them.
Hi, Al. Thanks. We're really happy to be here and share our materials. Do you want to say a quick hello, Patrice?
Hello, also very excited to be here and to learn and to grow with you all today.
Great. So if we want to switch to that first slide, or slide 4, we have a collection of materials. So we're going to talk about a lot of different things today. Two of the specific kind of projects we've worked on, Our Beautiful Planet and Health Data Well have landing pages, and those are going to be found in the collection, as well as some other kind of sense-making support tools for you that we're going to talk about. So anything we talk about, you'll be able to come back to this. There's a QR code right there you can click and get on. And also, I think Cody is going to drop that link in the chat for you, so you're able to access it. But don't feel like you have to keep going to that. If there's another link, we will drop it when you need it exactly. And you can move to that next page. Slide, I mean. Okay, so take a moment and just read these stats. And yeah, I just want you to kind of think about these stats and what they might mean. So when you take those combined, that's some pretty heavy heavy facts. Like, there are things happening that are making students sad because they don't feel like they have any control or ownership or um, way to deal with it. And on top of that, there's just not a lot of teachers that are trained to be able to help students make sense of these things. Finally, if students could make sense of those things, we would be able to change the outcome of what's happening to our planet with regard to climate change. So thinking about creating instructional materials to help teachers be able to do this with students is really an important part of our mission. So as we go through what we're doing today and talking about how we're going to do this, just kind of keep those stats in mind as our why and our purpose. Next slide, please. So where did our ideas come from? We didn't make this up. We're all experts at NSTA, but we aren't the major experts. We take all the research and we use that research to do what we're doing. And where we're getting those ideas mainly is from this framework for K-12 science education. This framework was built on research. First, UDL back in the 90s, there's all of this advice basically for instructional designers to make sure all students have access to learning. And between the 90s and 2011, 12 or so, when this came out, there was a lot of specific research on how students learn science. So UDL was for like just learning in general, and now we're talking about learning science. And to be able for students to really be able to learn science and make it their own understanding, they need to be actively engaged in science and engineering practices. So they're able to, over time, have ownership of these cross-cutting concepts, that they can apply these lenses to think about how to figure out these different problems or explain these phenomena using these core ideas. Or, we think of just the facts of science, but we're not telling students these facts anymore. We're helping them to figure them out for themselves. Okay, next slide, please. And why is this important, and who is it helping? We have these groups of students, and if you think about No Child Left Behind, some of these groups were called out, but the Next Generation Science Standards, which are a group of standards that many states have adopted, or a version very close to the NGSS, there's an appendix that specifically target each of these groups. So when you're thinking about economically disadvantaged, multi-language learners, folks of different races and ethnicities, those were also in No Child Left Behind, but this is going beyond, because we're not only thinking about those students, we're adding some different kinds of groups of students. We're thinking about gifted and talented as well. So when we talk about all students, we're not talking about trying to only target struggling students. We're making sure all students, including gifted and talented students, and alternative education programs are getting that same access. All right. Next slide, please. So when we look at the framework, and you take it all in, it calls for some major shifts in education and how we do things. So this first shift in, if you think about traditional science classrooms, you think about lectures and taking notes and kind of absorbing information, which I really liked, actually. I love it when people tell me things, but not all students do that. Not very few students really like that kind of instruction. But now we're making it a lot more relevant to them. We're asking them to explain phenomena. And when we say phenomena, it's not something we made up. It's something real that happens. You can observe it. And it might be something students are really familiar with, but they never even thought to explain it. And once we ask them to explain it, they're like, wait, I guess I can't explain that. So it's actually really engaging to them, because they realize they don't understand something. And that kind of, you notice here in the slide, it says, and design solutions to problems. Problem solving as well, but whenever we have an engineering lesson and we're trying to find a solution to a problem, there's a phenomenon behind that we have to explain first before we can design design a solution. So being able to explain those phenomena is really important and central. That next shift is to explain the phenomena. We're actually doing science. So we're using the science and engineering practices to uncover those core science ideas I mentioned earlier. So we're not telling students something and then doing a lab to confirm what we told them. They're actually figuring out those ideas through doing the science. So they're investigating, they're asking questions, they're analyzing data, and all those experiences that are very carefully designed to do so. They're figuring out those ideas. And then the third shift is really important. It's coherent learning progressions over time. And why this is so important is because it's coherent from the student's perspective. So when the student knows why they're doing the next thing, and it's their idea that they need to do that next thing, it's more meaningful for them. So instead of saying, oh, now we're going to do this lab or this investigation as a teacher, you ask the students what they need to know next. So we might have just figured something out, but that brings up some more questions. And now, how are we going to answer those questions? Students will have their own ideas for how to figure that out. So being coherent from the student's perspective is really, really important. Okay, so that was a real quick general kind of overview of the background of how we're thinking about designing some of these lessons and units. And now Patrice is going to take over and dive into one of these with a little more specificity.
Thanks, Holly. Next slide, please. Oh, thank you. So yeah, Holly was just explaining about how explaining phenomena and solving problems are a big part of the instructional shifts that we use to help design our sense-making approach to writing lessons. And now let's connect in the climate change piece, since that's the other piece of this session today. So these are all lessons that focus on either climate change phenomena or climate change problems, or both. Because as Holly said a few minutes ago, to be able to solve a problem, you first need to understand the phenomenon behind that problem. And this also ties back into those studies that Holly mentioned a few minutes ago and our why behind this. So if students are feeling anxious about climate change, or feel that they don't have agency, or they don't have control over some of these things happening, giving them an opportunity to figure out why is a certain change happening, and then thinking about potential solutions to that problem is a helpful way of addressing that anxiety. And the great part about that is that you're also helping them figure out those science ideas, as Holly mentioned before. So these lessons, as well as several others in our Daily Do library, are great opportunities for students to engage with climate change phenomena and problems. And going back to the third study that Holly mentioned about not a lot of teachers having training in how to teach climate change, all of these lessons have guidance in them, either directly written in, or we link out to resources about the best ways to frame climate change discussions. And two quick things that I'll point out is that we really do recommend that you bring an environmental justice frame to these discussions. And just to quickly read from the EPA, part of how they define environmental justice. The goal is for everyone to enjoy the same degree of protection from environmental and health hazards, and to have equal access to the decision-making process, to have a healthy environment in which to live, learn, and work. And I think really that second bullet, that equal access to the decision-making process, is where we're really going to empower a lot of our students. And I think that's where we should focus a lot of the energy, to make them understand that they have a right to be part of the decision-making processes about our environment that will affect their day-to-day lives. And one other quote I want to read real quick is from a teacher, a physics teacher, in an article that I read the other day. And I think this perfectly sort of encapsulates what we're aiming for. So Kim Lee, a high school physics teacher, said, "Students have to be able to visualize themselves with their own individual skills and talents as having the potential to be part of a multifaceted solution to these complex problems." So that's what we're aiming for, is to move from anxiety or sadness about climate problems to feeling like, hey, I have these ideas, I have these skills, and I can be part of the solution to these problems. Next slide, please. So the lesson that we're going to focus on today is about wildfires in California. And unfortunately, wildfires have become a newly relevant phenomenon to a lot of us in the United States this summer, with the wildfire smoke from Canada affecting air quality in lots of places far away from where the wildfires are actually happening. And as we go through the lesson, I'll also give you some ideas about ways to make it more specific to your state if you don't live in California or one of the other states that is mentioned in the lesson. Next slide, please. Okay, so in a moment, we're going to look at some data, and excuse me, in an effort to show you some of the ways that we get students to figure ideas out, as Holly mentioned, I'm going to ask you to act as a middle school student. And when you look at the data, think about what would a middle school student notice and wonder about this data. So if you have a piece of scratch paper next to you, go ahead and make a little table right now. If not, just prepare yourself to both notice things about the data that we're going to look at in a moment, and also wonder or ask questions about the data. Okay, next slide. So this is a little small, so I'll ask Cody to put in the chat a link to this data table so that you can see it better, because I realize that this is very small on the slide. And we'll give you about 2 minutes to look at the data presented here and record either mentally or on a piece of paper what you noticed about this data and what you wonder. Okay, take 1 more minute to record what you notice and wonder. Okay, so if we were doing this with students, the next step would be to ask them to turn to a partner and share what they noticed and wondered with the partner. But since we're meeting virtually today, I'll ask you to put in the chat, what are some things that you noticed, just the noticings right now? What are some things that you noticed about this data? So I see that a lot of fires are caused by lightning is something that was noticed. If there's more structures, there's more deaths. Most of the fires on the list are very recent, within the last 20 years. Another one's noticing that there were only 2 fires listed here before 2000. Great noticings. And what do we wonder? So now you can put in the things that you wondered or the questions that you had as you looked at this data. Someone's wondering, how can you prevent fires caused by power lines, right? If that's a problem, how could we potentially prevent that? And yeah, in general, for each of these causes, how could we prevent them? And why were there so many deaths associated with the North Complex fire compared to other fires? How can we prevent these human-related causes? You know, why are the acres impacted increasing over time? Right. And people asking, like, why are these fires getting bigger? And why have 14 of the 20 largest California wildfires on this table happened in the 2010s or 2020s? Yeah, what is it about recent years? Someone's asking. Is it temperature, rain, snowfall? Okay, people are making connections to weather. That's great. So where you would take this, the conversation from here is you would ask students to think about, are there some big questions that would cover a lot of these smaller questions? Could we sort of summarize these questions into one or two big questions? And hopefully they would land on something similar to the question that's the title of this lesson: why are wildfires in California getting bigger over time? But the important thing isn't that they land on that exact wording. The important thing is that they land on a question that is authentic to them. It's something that they are genuinely curious about, and that would lead to investigating both what are the causes of big wildfires. So some people are starting to already ask questions about those causes. And then what is it about California that has led to those ingredients being available in the last decades? So as long as it's a question that would lead to investigating those two things, it can be worded in a different way. So don't get hung up on it being exactly worded as it is in the NSTA lesson plan. The important thing is that students have a real need to know. Okay, next slide. Okay, so from here, the next step is to have students make connections to related phenomena, so things that they've seen in their everyday life. So they were just reading about really, really big fires, but most of us have seen fire, a small fire, in our day-to-day life. So you would ask them, what do you know about fire on a smaller scale? So either, seeing a piece of paper burning, or seeing a campfire, things like that. So take about a minute to think about, what do you know about fire from your day-to-day experience? And again, try to think about what a middle school student would say. So we'll give you a minute, and then I'll tell you to put your ideas in the chat, what you think about fire. Okay, so go ahead and put in the chat your experiences with fire. and what you know about what fires need. And again, if we were doing this with students, we would first give them an opportunity to speak with a partner before we came together as a class to discuss this. But for now, we'll use what's available to us, which is the chat. Okay, so I'm seeing some ideas. Oh, that they say not to start fires when it's been dry. So again, bringing in that weather connection, that if there hasn't been a lot of rain, it's not a good idea to start fires. Someone saying that fires can spread underground through the root systems. Someone's talking about what fires need. So someone's saying that fires need air and fuel and heat. So I wonder what fuel is. Maybe we can investigate fuel some more. Someone's saying that they've been to a bonfire and that there's enough energy from the bonfire to cook food on them. And sometimes you're not allowed to use or to set a bonfire because it's too high of a fire risk. So again, we're bringing in sort of weather a little bit, that sometimes the fire risk is higher than others. And another person saying, yeah, hot and dry is not, that's the time when fires might happen. So great, we have a lot of background knowledge about fires. And I guess the next thing we want to think about is, so thinking about like a small fire, like, you know, thinking about which would be a bigger fire, lighting a single piece of paper on fire or lighting a whole newspaper on fire. Thinking about how do we get from a little fire to these huge fires, and what's that needed ingredient that causes such a big fire to happen. So, excuse me. So what we're going to do next is we have some questions about what's needed to get a big fire. So we're going to watch a quick video that will help us think about what a fire needs and what could potentially start or stop a fire. And yeah, you can go ahead and play the video whenever you're ready. And there's no sound, so you're just going to observe and make a connection to, in your mind, to a wildfire. How does this connect? Okay, so we watched that film or that short clip, and let's go back to a word that somebody had thrown into the discussion earlier of fuel. So looking at that video, what would you say would be best described as the fuel in the fire? Like, you can go ahead and put your ideas in the chat. What would we say is the fuel? Just based on whatever you've learned about that word in the past. It's okay if you're not sure, but what would be your best guess as to what in that video is a fuel? Yeah, so some people are saying that the matches are fuel. So, or some people are getting even more specific and saying the phosphorus in the matchstick. So we said that a fire needs a fuel to burn. So when you have fuel, when you have those matches all in a line, the fire burns, right? And then what happens when there is no fuel? Go ahead and put your ideas in the chat. Right, so the fire stops. If there's no fuel, there is no fire. So going back to what we saw in that data table about the fires getting bigger and bigger in California, what prediction could we make about the amount of fuel available in California over time? Go ahead and put your ideas in the chat. So what would your prediction be? Do you think there's more fuel over time in California, less fuel, the same amount of fuel? So some people are saying, I see someone saying that if you removed the fuel, that could minimize the fire size. So maybe some people are saying that there must be lots of fuel available if the fires are that big. And some people are bringing in weather again and saying that drought has something to do with it. So I like this weather connection. So I think that it might be time to look at some weather data in California over this time, and then also to investigate this fuel piece more. So we have a data set that has information about both California as well as some other states. And it has weather data and information about some other things going on in those states that I think will help connect to what you all have been saying in the chat, so we can see what has been happening to the amount of fuel in California over time. So Cody, if you could put the student reference sheet link into the chat so people could look at that. And then if we could also move to the next slide. Great. So yeah, you can see there's a variety of information in this reference sheet. So you have a table with some data, you have some images, and you have some maps. So we're going to give you 2 minutes to look at all of that. And then we're going to discuss what you think about it. Okay, I know that wasn't quite 2 minutes, but I'm just being mindful of the time, and I want to make sure we have time to do everything. So I'm gonna stop you from analyzing the data and move forward. And we also won't have time to discuss this in the chat, but I will give you the sort of cooking show version and say that, what we hope that students would notice here is that there's something called an intentional burn or intentional fire. And they can see that in the picture on the left at the bottom, they're burning small plants, sort of close to the ground. And in this photo on the right, where there's a really big fire happening, there's a lot of that kind of brush and grass and plants down near the ground. And so that's a lot of fuel for that fire. Hopefully, as a lot of you are putting in the chat, that hopefully they'll also notice that California has been really hot and dry. And so if you have a lot of hot, dry fuel, that's a perfect recipe for a really big fire. And if you do an intentional, I think out of this data, they won't necessarily know exactly what an intentional burn or intentional fire is, but hopefully they'll start to see that maybe it's reducing the amount of fuel necessary, and that places that are doing some intentional burns are having less big wildfires because there's less fuel available. But they're not exactly sure what an intentional burn is and how that works and how you could do that safely. So they're going to have a lot of questions coming out of this data. And going back to what Holly said before, the creating like coherent learning sequences, they're going to have questions that will lead them into watching the film that they're going to watch next. So instead of the old way of the teacher just starting the class with, okay, today we're going to watch this film about wildfires and intentional fires, students are going to look at this data and have a lot of questions about intentional burns. And then you'll say, well, that's great that you have all those questions because I have this video and I think that'll help answer these things that you want to know. So at this point, we would go into the video, and if you can change to the next slide and start the film. This is from our partners at KeyCam Media, and that's part of the Our Beautiful Planet
What
project.
makes Hugh's work so timely and urgent is that year after year, the fire problem keeps getting worse.
The state of California is on fire.
Firefighters battle one of the largest fires in state history.
Hundreds of wildfires burning at once have ravaged more than 1,200 square miles this week.
In total, the area burning is larger than the entire state of Rhode Island.
California is just one of many places in the world where wildfires have become bigger and more frequent, in large part because of climate change.
So what happened here was it burned a lot hotter.
Hotter summers and prolonged droughts have been making plants drier and more
That
combustible.
one didn't.
But Hugh and many other scientists say that when it comes to the mountains and forests in the western U.S., there's another cause that's just as important. A fundamental misunderstanding of the role of fire in nature that's deeply rooted in American history. For centuries, the Native Americans who inhabited the West understood that intermittent wildfires, sparked by lightning, are a normal occurrence. They foster the natural cycle of decay and regrowth. So they set intentional fires to influence that cycle for their own benefit. By burning plant species, for example, that compete with oak trees, the source of the acorns that were a staple food for many Western tribes. But the European Americans who seized control of the West forced the Native Americans off their land, putting an end to intentional burning. The federal government, which managed huge swaths of Western land, saw fires only as destructive. For more than a century, it was national policy to try to prevent or quickly extinguish all forest fires. In part, to protect the profitable logging industry, and also to safeguard the homes of the many new settlers in the West. So trees and vegetation that in past centuries would have periodically burned no longer did. The amount of combustible fuel in the forests just kept on growing, setting the stage for the rash of huge wildfires we see today.
The largest single wildfire in California history on the doorstep of more historic small towns.
I think it's the classic short-sightedness. Sometimes you might assume that people might actually understand the long-term implications. In this case, no one even thought about them.
But eventually, we did learn from the past. Today, Native American tribes like the Karuk in California have revived the practice of intentional burning.
I hope to see us manage the lands more with fire. Like that's the ultimate goal, is to go back to how it's been done for generations, bring good fire back. It's not gonna stop it, but it'll help prevent the catastrophic fires that have been going on.
And the value of the Native Americans' ancient practice is now recognized by the U.S. Forest Service, which is conducting its own controlled burns in different parts of the country. While these efforts can reduce some of the fire risk that's built up in our forests, they're nowhere near enough to bring an end to the wildfire crisis, which in the West, scientists predict, will grow steadily worse.
So these ones here are the ones that you sampled up on top of the rig?
We'll be measuring these plots for at least 3 years. And all of this will give us some predictability as to what that chaparral will look like in the next 10, 15, 20 years.
Hugh hopes that a better understanding of which plants are not surviving will help forest managers to identify the species that most urgently need to be replanted.
I mean, I'm sure the world could live without chaparral. It's a building block. It's like you pull one brick out of a building, it's still there. But when you pull a bunch of them out, it's not there any longer. A lot of these questions about our ability to sustain ecosystems into the future under all of these different components of global change is going to depend to a great extent on what we learn in places like California. We care a lot about the world, the planet, humans' role in it. And I feel as if that we can do things that we can be proud of, that we can say to ourselves that we left the Earth a slightly better place than we showed up. And that's what drives me.
Okay, so, again, we have limited time. This is a 2-day lesson, and we're, fitting it into a 1-hour session with also time to discuss some of the teacher moves. But the next move you would do with the students is have a discussion with them, both, again, at the pair level and at the whole class level, where they can put together the ideas that they identified both from analyzing the data and from watching the film to build an explanation of why the wildfires are getting bigger over time. And, another potential next step would be talking about the potential solutions to the problem, which are presented in the video. Next slide, please. So in all of the Our Beautiful Planet lessons, there is a profile of a scientist or engineer who's working to solve some of these problems. And then also in the films, as you saw, there's a variety of other people who aren't science and engineers per se, but use science and engineering practices such as the firefighter that you saw in this video. So, really great thing about this project is that it exposes students to a lot of potential future career paths. Next slide. And I'll pass it back to Holly at this point.
All right. Thank you, Patrice. All right. Cody, could you? Yeah, awesome. You got that message. Thank you very much. Okay. So hopefully, we had to move really quickly and I want to have time for some questions. So we're just going to really quickly look at this continuum. What we did is we tried to create this lesson that is more in the sense-making frame. So if you read the bullets on the right, the teacher's focused on helping develop conceptual understanding. Students are focused on understanding or explaining something. We didn't get into assessments, but assessments aren't about like right or wrong answers. It's about having these conclusions, generalizations, and explanations they can create. And no lesson is going to be perfectly one way, or hopefully not the other way either, this traditional information like sit and get kind of thing. But it's this continuum, and we're really trying to shift more to this sense-making frame. Next slide, please. And to just kind of pop back to this like idea of sense-making, and we talked about those critical shifts. When students are experiencing curriculum or lessons and units that have been written with these shifts in mind, they're going to be experiencing a phenomenon. They're going to engage in these science and engineering practices that we analyzed. We made observations. We did a lot in this short time that was super abbreviated. But really importantly, that we didn't talk about at the beginning, but I really want to put a point on now, is students are sharing ideas. It's hard to do that in a virtual setting, but in a classroom, they're thinking, they have time on their own to think, then they share with someone, a small group or a partner, so they can feel like, oh, okay, I have some ideas that I can actually say in the whole class. And then they have the courage. They're like, oh, my idea isn't crazy. I can say that out loud. So there's so much more participation in these whole group discussions. And all of the students really do feel like they're part of the knowledge building. And that's the whole key difference. All of the students in the whole class are part of the knowledge building, and they really believe it. So again, they're using those science ideas, cross-cutting concepts. They're making these explanations, but they're all doing it together. But each student really feels a lot of ownership in those explanations. So that was super abbreviated. And Patrice, did you want to say something? It looked like maybe.
Oh, no.
Okay, cool. But I think we have a tiny amount of time for questions now. If we want to, should we open that up?
I see. Oh, go ahead, Mom.
Go ahead. You got it.
So I see a question about Florida, because that was one of the states that we had data about. And it reminds me that I meant to say that a place where you could put in your own state's data would be in that student handout. So you could include data about your state as well. Most states have, a forestry service or that you could look up, and the information is pretty easy to find. The question of, is Florida a fair comparison to California? I would say no, and that's why we added other states, because both in terms of size and climate, it isn't, a apples to apples comparison. And that's part of, if there was more time for us to have a real discussion, that I would have hoped that somebody would have brought that up, that that when you're comparing states that, have vastly different numbers of acres involved, that just comparing those two to each other that's a limitation of the data available. So good questions. And in terms of how's the land left after the intentional burn, I'm not sure. I'd have to look into that. I think the main thing that I looked into is just reducing the amount of dry fuel available for a wildfire.
I see a question about resources for elementary. We do have elementary units, just not our Beautiful Planet ones at this time. But we do have other elementary units on it, just are in our catalog of things we've developed. And then a good question here at the end, how do you handle students' contributions and sense-making framework that lead to faulty assumptions? So that is really important, because getting those faulty assumptions or ideas out there and making students claim them. So usually we'll have them make a model or something of their initial ideas and get them down on paper. And as they're over time collecting more and more evidence, it's actually proof against their initial idea. So they're actually figuring out that their own original idea wasn't the most, they have these understandings that they came in with, but they're improving their understanding, they're building their knowledge. And that's why we have these facilitated class discussions. So if something's going off the rails, you ask other students if they agree, and you continue facilitating until you get to that getting pointed in the right direction.
Thanks, Holly. And I think we are at time, but we do want to encourage you. Our emails are here. Please do email us. I'm sorry we couldn't get to everyone's emails today or questions today, but email us and we'd be happy to respond to you. Another thing to note, in the collection, there is a short survey about what you think about Our Beautiful Planet, and whether you'd want to potentially give more feedback in the future. So if you're interested in that, fill that out. And yeah, don't hesitate to reach out if you have any questions about these materials or any of the other materials on the NSTA website. And we really thank you for being here with us today and being so active in the chat.